All right, good day everyone. This is Jason Straight with the Pats Cloud Virtual Group. Our presentation today is Tour of Azure SQL with Microsoft, and our presenter is Anna Hoffman, who is with Microsoft. Before we get going here today, I just have a few announcements. So the first announcement is that our virtual group is sponsored by Microsoft Azure. They're helping to make sure that we can continue to have these presentations, make sure that we have the tools and technology we need to do that, and also to help make sure everyone knows what's available for them out on the Azure platform, which is pretty much what we're looking at today. Seeing as we have Microsoft presenting here today, there will be at the end of after the session a couple gift certificates sent out to folks as kind of a thank you for attending the session today. If you are not yet a member of the virtual group, I do recommend doing so. You can go out to cloud.pass.org to see our upcoming sessions. And then also while you're out there, if you're interested, if you've got something interesting that you want to share about what you've been doing with building data platforms in the cloud, I do recommend that you send an email to us at cloud@pass.org, or you can fill out our call for speakers form that's out there. Just fill that out, give us the details of what you've done with your cloud solutions and what you'd like to present, and we can get you on the schedule. Coming up this fall is that's a very poorly spelt virtual PASS Summit for 2020. This year, due to the coronavirus, they've opted that PASS Summit will be a virtual event. And so if you have not yet registered, you can get a discount on that registration. You can get $50 off using the discount code that's there on the screen. This virtual group is part of a number of virtual groups that PASS helps to put together. Some of these focus on different languages and like Global Chinese and Global Spanish. Others focus on different areas within data platforms and how you can leverage those to help build things out, like PowerShell or data science. So lots of different opportunities to continue to learn about building out your data platforms. Throughout the session, I expect some of you are going to have questions. We have a number of folks on here from the presenting side to help answer some of those questions throughout the session. And then at the end, any remaining questions we'll go through with a live Q&A. And so if you have questions, please type them into the Q&A panel. And with that, I'm going to hand things over to Anna for her presentation today. And let's see.
Awesome. Thanks so much, Jason.
Oh, you're welcome. And as soon as I verify that you've got things going, I'll just mute myself.
All right. Let me know if you can see my main presentation screen.
Yep, it's coming through perfect.
Awesome. And you can see me and hear me and we're good?
Absolutely.
Awesome. Okay, well, great. Well, I'm going to get started then. Thanks, Jason, for having me on. I'm super excited to be a part of this. I try to be pretty active in the PASS community, and so this is a great way to do that in times of uncertainty and being virtual. On that note, Jason did mention the PASS Summit, which is happening later this year and virtually. I do want to say that you're going to see a glimpse of some things today, but if you're interested in going deeper, Bob Ward and myself are doing a whole pre-con called the Azure SQL Workshop, and we'd love to have you there if you are coming to PASS Summit and considering a pre-con. With that, I want to go ahead and get started. We're going to do tour of Azure SQL. So I'm going to show you the different options and kind of what to use when. And if I could progress my slides, you know, I've done this a few times, and really the purpose of what I'm doing is to give you a tour of Azure SQL, one, and two, to show you the different options and show them in a light that is positive, because we really have these options not to confuse you or to make things complicated, but really to help you get exactly what you need for your organization or a specific project, and not have to overpay for extra stuff, as well as kind of optimizing and getting the best performance for what you're looking for.
We're not asking for more people. We're just adding for the docs people you have to do their job properly. But
sorry.
That was Matt. We got him muted.
Okay, got it. No worries. Sorry, I just wasn't sure if someone had a question, but we're going to get started. and we'll talk about what to use when, and hopefully by the end of this, what you'll feel is that Azure SQL and everything really within that whole family we're going to talk about today is going to empower you to do more as opposed to confuse you. And the way we're going to do this is by talking about overview, kind of what's in the Azure SQL landscape today, and then we'll dive into each of the different deployment options, and you'll soon learn what that means if you aren't familiar already. And then finally, we will talk about service tiers and some of the other choices that can help get you better performance. I think I lost my screen share.
You did. I'm sorry about that.
No problem. Let me know if you can see it now.
Yep.
Awesome. Okay. Here we go. So before I start giving you a tour and telling you about what to use when, I like to take a step back. So let's step back to 2008 at the PDC. This is the Professional Developers Conference, very similar to what we have now called Microsoft Build. And the gentleman you see on the left is Ray Ozzie, and he was our chief software architect at the time. And he put up this slide and basically launched our cloud, which at the time was Windows Azure, project name Red Dog. And the reason I bring this up is because from the beginning of Azure, literally front and center has been SQL. So that's really cool. And then I also found a blog post from 2010, which was saying what to use when for Azure SQL database. And you don't need to read all these words, but the highlight is, they said you do not need to provision hardware for, install, or patch it. And you also do not need to architect a database installation for scalability, high availability, or disaster recovery. Now, I think this statement is still very, valid today when it comes to what to use when for, the whole family of Azure SQL. So I just thought that was a little interesting fun fact. And in the deck, which I will share out, I share links where you can actually go watch this launch and actually go read these blog posts. Now, since then, we've come a really long way, and being Microsoft, infamously, we've changed names a lot. So that's just one of the things I like to call out here, which is kind of funny how we went from CloudDB to SQL Data Services to SQL Azure, so on and so forth. And finally, in 2020, we are settling, hopefully, on Azure SQL. And Azure SQL is really meant to envelop most of the deployment options that you're seeing on your screen today. And you can see we've really expanded, and we've had several different versions, and we're going to talk about those today. So I want to talk about our latest rebranding exercise of Azure SQL. And the way I like to look at this is layers of what you have access to versus layers of things that are abstracted away from you. So if you have access to it, this is great because you have more control, but this also means you have to do more management and update and patch and that sort of thing. So the first option is infrastructure as a service, or you'll hear me call it IaaS, and that is SQL Server on Azure virtual machines. So this is just SQL Server running on an Azure virtual machine. You pick the OS, you pick the SQL Server version, but again, with having access to, you have the infrastructure abstracted away from you, but you still have access and therefore responsibility for the OS and the SQL Server. Now, as we abstract one layer higher and say, I don't really care about managing the OS or the infrastructure, I just want a SQL Server, that's when we say Azure SQL Managed Instance is going to be the best fit for you, because what you get is you get a managed SQL Server, and this is a platform as a service or PaaS service. And we'll talk a little bit more about that, what that means. And then finally, if you say, I don't even need the SQL Server, I just want a database and I want to get to developing or building new intelligent applications. And that's where Azure SQL Database comes in, where you just get a database and you can kind of get some of the unique innovations that we've been working on the past, 10 plus years. So now we're going to dive deeper into each of these deployment options, what challenges they address, and then some of the extra benefits you get from being part of Azure SQL. The first is SQL Server on an Azure virtual machine. So I like this phrase, the promise of the cloud while maintaining OS control. So what does this mean? Customers move here because they want to come to the cloud. They want to start taking advantage of some of the overhead and assistance that we can help with, but they might have something that relies on the OS. For example, we see many customers that run third-party applications that need access to that OS. So SQL Server in an Azure virtual machine is going to allow you to do that, right? Because you're getting a virtual machine. We have support for vast OS versions as well as SQL Server versions. So you can really just kind of lift and shift exactly what you're using on-prem in Azure. And you get all the features because at the end of the day, it's just SQL. Now, what you do get if you come to Azure virtual machines is you can get things like free extended security updates. A lot of customers we see moving to the cloud are trying to get off of SQL Server 2008 R2. Fun fact, just because we reached into support doesn't mean all of our customers have moved up or upgraded, but you are going to get that extra security if you move to Azure in a virtual machine, SQL Server in a virtual machine. Now, one customer I really like for this is a customer called Allscripts. Now, I like this customer because what they did is they were able to use Azure Site Recovery to basically fail over about 600 virtual machines in a few weeks. So it was a pretty fast and smooth migration. And the really interesting thing is once they got to Azure, they started to evaluate some of the platform as a service capabilities in managed instance. And eventually they started moving some workloads to managed instance. So I think they're a really good example of one approach to migration, which is taking a phased approach. So they got everything in Azure virtual machines, and then they started to evaluate the other services and benefits that the cloud has to offer. Now, I'm not going to dive too much in here. There's a lot more we could talk about Azure virtual machines, but I want to clarify or demystify this idea of the two ways you can get SQL Server on an Azure virtual machine. Now, the first way is that you go through the marketplace, which basically means you go through the Azure portal, you find the image that you want with the version of SQL Server that you want and the licensing option that you want, and you basically just deploy it, and it already has SQL Server installed. Now, what we found is many folks in the SQL community are used to doing what? First, you get some sort of virtual machine, and then you install SQL Server. So this is the second option, and that is a self-installed SQL Server on Azure virtual machine. Now, fortunately, we've recently, well, not so recently anymore, but released this thing called Resource Provider. So this is going to enable you, even if you don't use our pre-built images, you can still get the benefits that we provide if you enable this thing called Resource Provider. Now, one highlight I wanted to call out, because I think it's really exciting, is advanced data security. Now, this is something that was previously only available in our platform as a service offerings, but because of some of the work that we've been doing, and as we're continuously innovating, we've been able to enable advanced data security services in preview in SQL Server and Azure Virtual Machine. So what does this mean? This means that you can do some configurations and installations and set this up on your SQL Server on Azure Virtual Machine and get things like advanced threat protection, which can do things like SQL injection and other security threats and alerts, and basically give you capabilities that were previously only available in PaaS. So that's just one of the many things that we're working on for SQL Server in Azure Virtual Machines. Now, it brings me to this interesting conversation of IaaS, so that's infrastructure as a service, that's SQL Server and Azure Virtual Machine, versus PaaS, so your Azure SQL Database, your Azure SQL Managed Instance. What's kind of the difference, and how do you go about evaluating what's available? Now, if you look at this list, I'm not going to go through all of these, but if you look at this list, these are a lot of things that people look for, correct? And many of these things with IaaS are possible for you to configure. For example, advanced data security. You can configure that on your SQL Server virtual machine. You can basically install an agent, connect it to log analytics, and get up and running. But with Azure SQL Database, a lot of these capabilities are more built in, and with Managed Instance too, our PaaS capabilities. Advanced data security is kind of built into the experience out the gate. I think it's something that will come to virtual machines soon, but my point being, while things are possible in IaaS, in PaaS they're much easier, and oftentimes they're already set up for you. Another one is SLA. With our PaaS offerings, you can get an SLA for your SQL Server Managed Instance or Azure SQL Database. It's a little bit different with virtual machines. And the big highlight, of course, between IaaS and PaaS is this idea that PaaS is versionless SQL, meaning you never have to upgrade, you never have to worry about patching, you don't have to worry about the OS. Like, we're always going to be keeping you up to date, and the responsibility falls on us to make sure you don't get broken and you're up and running, up to our SLA. So that's a little bit of the differences. We'll go into more throughout this session. I like to call it the power of PaaS, and I'll show you a few demos of what I think of the power of PaaS and how it's different from what you get in SQL Server on premises and even SQL Server and Azure Virtual Machine. So I'll take that as a lead in to Azure SQL Managed Instance. Now, the reason we came up with this product, because this product came relatively recently compared to Azure SQL Database, is that we had a lot of customers that wanted to move to Azure SQL Database. However, they needed something like the instance scoped features. And when I say that, I mean things like Service Broker, Database Mail, CLR, SQL Server Agent. They needed these instance scope features to more smoothly move to the cloud. And since in Azure SQL Database, you just get a database, they didn't have access to these things. So this was a big reason why we built Azure SQL Managed Instance. And really, when you move to Azure SQL Managed Instance, you're going to get more of the SQL Server surface area. You're also going to get native virtual network support right out the gate, so you can deploy this as an extension of your on-premises network. And additionally, working with Bob, he says you get the best of SQL Server and the best of Azure in Azure SQL Managed Instance. Now, one customer I like for this is a customer called Komatsu. Now, Komatsu moved about 1.5 terabytes of data very quickly, very smoothly, without a lot of code changes. And this is the really powerful part, which they reported back to us, is that they saw a 49% cost reduction and 25% or more performance gains. And that's pretty significant. That's not like, it was like a little faster, a little more available. Like, it was pretty significant that the changes and the impact that they saw from moving to Azure SQL Managed Instance. Now, power of PaaS. One common topic is, having this idea of read scale, whether it's in your region or whether it's across the globe. Now, in Azure SQL, there are two options for this. There's geo-replication, which basically allows you to create multiple replicas in other regions, including your own region. And then there's auto failover groups, which, like the name suggests, allows you to create a failover group with another region and then do an automatic failover. And what this also means is that if you have to do an auto failover, some sort of failover, you don't have to change the connection strings. You point to the failover group, and we're going to direct you to the primary or the secondary, whichever one is at that state at that time. Now, the reason I bring this up and the reason I say the power of PaaS is because previously in the on-prem world, this is something that was very complicated to set up. It would take a lot of, logistics and infrastructure, depending on where you're going across the globe. It could include travel or working with other teams or all sorts of things. But with PaaS, with Azure SQL PaaS, this becomes very easy. Now, one call out I do want to make is that auto failover groups is available in Azure SQL Database and Azure SQL Managed Instance. However, geo-replication is only available today, at least, for Azure SQL Database. So all that being said, I want to show you an example of auto failover groups. So I'm going to switch over to my virtual machine. And let me just kick this off. There's a lot of stuff going on, so stay tuned and I will let you all know what's going on. So let's start on the left side of the screen. So hopefully you've all seen this before. This is Azure Data Studio, an awesome tool that you can use for Azure SQL services as well as SQL Server services. And what I have here on top of that is a notebook. And notebooks are a powerful thing. They came from the data science community, and why they're so great is it allows you to integrate what's called like a text cell with code cells that you can actually run and store the results. So I could run this, store the results, save it, send it to another colleague, and they could see what my results were, or they could run it on their own. Now, Azure Data Studio has added support for a lot of different kernels. So that's basically the language that you're seeing in the cell. So here I'm using PowerShell. And what I'm going to do, just move this over just a little bit, is now kind of explain what I've done. So this is, again, this is an auto failover group in Azure SQL Database. You notice that we're starting at step 7. I'm not going to show you all the steps. I will share out this notebook. It's on my GitHub. But just know that in 6 commands, basically, I didn't have to go anywhere. I didn't have to talk to anyone. Of course, that's a little extreme. You'd want to work with your team. But with 6 commands, I was able to deploy a failover group in another region. Now, what I'm going to do is simply just run this, and this is going to tell me what role each of my servers is in. So I basically stored as variables 2 servers. A regular server, that's my primary in this case, and then a DR server that I attached as a failover group, and I'm just calling it DR for disaster recovery. So what I can do is I can use this PowerShell command, get AZ database failover group, and select the replication role to see what role each of the servers is in at a given time. We see right now it's in a secondary, which is what you would expect when you first set up the failover group. Okay, so now what's happening over here? Let me just scroll up. What you're seeing over here is the result of a very simple Java application. And what it does is it connects to the failover group primary and the failover group secondary. And it basically tries to insert a row in the primary and then read that row that was just inserted from the secondary. And it's just going to report if it succeeded or it failed. Okay, so far we've seen you can set up auto failover groups in SQLDB or MI. The commands for MI are slightly different, but same number of steps. And then you can kind of leverage one of your secondary as a readable. And so what I'm going to do now is I'm going to invoke a failover. So I'm using this switch command, and this switch command basically says, okay, make the DR server the primary for the name of the failover group. Now, while this is happening, what you'll notice is I'm starting to get failures over here. So my inserts and my reads are failing as this failover occurs. And I want to take a second to say this is just another reason why retry logic, when you do move to something like Azure SQL, is so important. If there's any sort of blip in connectivity or a failover has to happen or whatever, you don't want your app to go down. So making sure you have retry logic implemented is very important. But you see, after 5 attempts, we were able to reconnect. And now we can run the same command except selecting the replication role of the DR server. And if I just run that, what we'll see is now the DR server, which was originally my secondary, so above it was secondary, is now the primary. So again, even failing over becomes very easy. Notice I didn't have to change any connection strings. My app is just able to completely start running normally again. Now, if I wanted to switch back, I use the same switch command, except I'm now going to make the regular server the main as opposed to the DR server. And I could check the status of the secondary as well. So you'll see, again, it will, I'm just going to scroll up, it will momentarily become unavailable as this failover occurs, and then we'll be back up and running. So to me, this is a great example of the power of PaaS, how it doesn't take very much commands or effort or time, and you can really get kind of a geo-distributed application. All right, let me get back to my slides. All right, so we talked about some of the benefits of Azure SQL Managed Instance, really turned out to be also benefits of Azure SQL Database and the power of PaaS. So I think this is a good lead-in to Azure SQL Database, which is the last main deployment option in the Azure SQL family. Now, there are many challenges that lead a customer towards picking Azure SQL Database, and that's really because Azure SQL Database has a lot of different options that are there to get you, again, what it is for what you need. So if you need, a huge amount, a really, really big database, maybe 60 terabytes, then you could move to hyperscale, which is available in Azure SQL Database. We also have support for serverless in Azure SQL Database. We have this idea of building multi-tenanted applications. And another thing worth calling out is you can get the industry highest SLA with Azure SQL Database. And this is because we have something called availability zones. And so basically you can spread your Azure SQL database across a region as opposed to being all in one place. It can actually be spread across, multiple data centers within a region, giving you even higher availability. And I forget what the number is for this. Bob and I calculated it the other day, but I think this availability is something like 30 minutes of downtime a year. I'd have to recalculate it, but very little downtime over the course of a year. The other thing I'll call out here is private link support. This is something we just went GA in March, and this is going to allow you to basically have a completely private DNS hierarchy, making your database more secure, only accessible if you come in through the private endpoint of a virtual network. Now, a customer example that I like is AccuWeather, and AccuWeather really just wanted to start developing really great applications. They didn't have to worry about the servers, they didn't want to worry about the OS, and immediately they were able to plug Azure SQL Database into other services like Azure Machine Learning Services, so they could start building more intelligent applications for their customers. Now, since Azure SQL Database, is the most abstracted version within the Azure SQL family, we do have some extra access to different telemetry pieces available in the service. And one of the things this allows us to do is leverage that telemetry using machine learning to actually recommend and implement indexes to create or drop or parameterize queries automatically. So this is another Power Paths thing that I like to show off. This is called automatic tuning. Specifically, we're going to look at automatic indexing. So actually, I'm going to stop this. Now, if I go into the portal, I have this database, Workload Insights Demo. It's an Azure SQL database. And on the left-hand side, hopefully this looks familiar for you all, but if not, if the left-hand side, if I go down to about the bottom, close to the bottom, I see Intelligent Performance. And I can select the Performance Overview, and this is going to show me a few things. The first, it's going to give me some query performance insights, but in the form of a nice dashboard. So this is something you get in SQL Server, but without this exact dashboard, which you can actually drill in, and I can actually see, which query is taking 60% of CPU, and you'll actually be able to drill into the query text. Now, a few of the things you see up here are recommendations. So this is part of that automatic indexing capabilities, any activity that has been done because of that, and any automatic pieces we've set up. And you'll see what that means in a moment. If I go to my recommendations, what I'm going to see is I have quite a few recommendations, and they're organized by their estimated impact, so high, medium, or low. And I see I have some create index opportunities. There's 2 of those. Now, if I click on the high one, because I want to investigate it, I can see, more information about what they recommend related to this query and how much space it needs, and the amount of impact they think it will have. I can also then do 2 things. I can either take a look at the script. So here's the script. I can select it all. I can copy it and implement it myself when ready. Or I can select this apply button and have the database advisor actually create this and validate it for me. That's the route I'm going to do. But I'm also going to say, hey, you know what? I am managing a lot of databases. If you see another create index that you think I should implement, go ahead and apply it. So I'm going to say automatically do that. So this is the automatic part related to it. Now, we are using machine learning behind the scenes to get us to this point, but this is an extra bit as well. So when I hit OK, what's going to happen? Let me make sure I hit OK. When I hit OK, what's going to happen is it's going to kick that off. You're going to see 2 things. My first create index, which was high impact, moved to a pending status. And this other create index also moved to a pending status because I said automatically apply these create indexes in the future. Now, why does it say pending instead of like applying or successful? The reason is it's going to wait till a time of low utilization, and then it's going to apply these create indexes because it doesn't want to interrupt our workload. Additionally, after it applies or creates the index in this case, it's going to monitor and validate that we actually saw the performance increase that we were hoping to see. If it doesn't, it will undo the action that it's done, whatever that action was. So this is really powerful stuff. really interesting how we were able to leverage machine learning in the telemetry to kind of give you a more intelligent database. Again, this is the power of PaaS, and this is something today you only get in Azure SQL database. All right, so we've talked a lot about the different deployment options. There are actually two more kind of sub-deployment options I haven't touched on, and these are this idea of pools. Now, the first one is within managed instance. Now, one thing to consider with managed instance, a single instance, is it takes a while to deploy. And the reason is because in the behind the scenes, in the back end, what we're doing is we're essentially deploying a whole ring for you, which takes time. It can take a few hours. This is something we're working on improving, of course, but one solution or mitigation for this long deployment time could be an instance pool. Now, an instance pool, the pool itself takes time to deploy because we're doing the same thing except on a larger scale. However, once you have a pool deployed, then you can easily deploy new single instances into the instance pool in much less time, and you've kind of pre-provisioned so you can have a smooth migration. In an instance pool, you can also host smaller managed instances, which can help if you want to move multiple instances that are not needing, say, 4 vCores. This is currently in public preview. The other type of pools, which has been around for years, it's generally available, is elastic pools in Azure SQL database. And this is really used for multi-tenanted applications. So I kind of mentioned this earlier, but what elastic pools allows you to do is resource optimize and kind of share between lots of databases. There's a customer called Paychex, and they run 600,000 customers using elastic pools. And this has been really great for them. And also from a management perspective, it kind of allows you to have more of a single pane of glass to look at. Now, once you kind of have picked your deployment options, there are some more options. Again, these options are all good things, right? We're going to talk about why these options exist. The next option is the purchasing model. Now, when we first launched Azure SQL Database a long time ago, we launched with this thing called the DTU model. The DTU model was meant to be, like it says, simple and pre-configured. At each level, you're going to get a set amount of compute and storage. And you just scale up and down depending on if you're not getting enough or you're getting too much, right? Now, many customers said, hey, we'd like a little bit more flexibility. And so later we came out with the vCore model. And so the vCore model came out, later, but early enough that managed instance actually only supports the vCore model. So that's something to consider. It's one less choice, if you would say, in managed instance. However, what are some of the benefits of the vCore model? You can independently scale your compute and storage. So this helps you get more of what you actually need and not kind of overpay because you need a lot of compute when you don't need that much storage, for an example. Another thing that's awesome about the vCore model and why I say Microsoft's recommendation is this opens the door to other cost savings opportunities. Two main ones. One is Azure Hybrid Benefit. So if you have existing licenses, then you can leverage those here to get a pretty significant discounts on your Azure SQL database or managed instance. The other cost saving is this idea of reserved capacity or reserved instances. So basically what that means, without getting into the details, is you can say, hey, I'm going to have this database, for example, and so I'm going to prepay in advance for this database. But because I prepay in advance, I'm going to get a pretty hefty discount for that as well. So the vCore model is kind of what we're going to continue to talk about as we talk about service tiers. So we have our deployment options. So, what level of abstraction and what service do you want? Then we have our purchasing model, which in managed instance is only the vCore. In Azure SQL Database, we have this legacy model that you can also choose, but the recommendation is this vCore model. And then you have service tiers. So there are 3 main service tiers we're going to talk about. And I thought it would be interesting, because I know this is PaaS and this is a SQL audience, to kind of talk about the architectures and how they relate to SQL Server, because it's very interesting how we were actually able to set this up. Now, the first service tier is general purpose. And as the name suggests, this is going to be what's best for most of our customers. They're going to be just fine running on general purpose. So how does it work? It behaves like a failover cluster instance, if you're familiar. So what happens is you have this application. So we have our application, and it can hit the control ring, which has gateways in it. And depending on how you've set up connectivity, which I won't get into, but I can share resources on, we'll either go straight to the gateway and then to the database every time, or you'll go to the gateway once and then directly to the database. This is in all service tiers. Anyways, so in general purpose, your database has a primary replica. And running on this VM, if you think of it as a VM, is the TempDB running on local SSD. Now, the data and log files are stored in Azure Premium LRS storage. So what that means is the data and log files are not located on the local SSD, but they are located in the same region on premium storage and locally redundant storage. So you have some redundancy there. Additionally, your backup files are stored in Azure Standard Storage with RAGRS, which means globally redundant storage. So just by deploying, you have a globally redundant database with locally redundant data and log files. So that's awesome right off the bat. Okay, so how do failovers happen? Now, these are going to be, so if I step back for a second, the Azure backbone is kind of built on this thing called service fabric. Now, if for whatever reason we need to fail you over to a new node or new VM, we will do that. And the way this works is similar to a failover cluster instance. We'll look for a node with spare capacity, and then we'll kind of move you over and repoint your TempDB to the same data and log files, which is on LRS. Now, this connectivity redirection is built in, but this recovery time can vary. And we'll take a look at that in a few moments. So that's the general purpose service tier. Now, the next service tier is business critical. And this one's really interesting. So far, what you're seeing looks pretty similar, right? We have our application, our control ring with gateways, and our primary replica. However, this primary replica, since it is business critical, it's meant for workloads that need more low latency and faster recovery than general purpose. On that local VM, what you have is the data, the log, and the TempDB file. So it's all kind of there. Additionally, what we do in the back end is we deploy an always-on availability group. This means you're going to have 3 secondary replicas automatically created and 4 at any time. And just like before, your backup files are still going to be stored in globally redundant storage. So this idea of having your backup files in globally redundant storage is really awesome because it means if something happens in your region, something catastrophic happens, you already have backups in other regions, so you can geo restore to a new region in a time of downtime, without having many issues. Okay, so we talked about failover before. Again, this failover is going to happen automatically if we detect something is up, or you can actually force a failover if you need to for whatever reason. But it's going to be based on the service fabric. And it's really fast because all we do are we're going to change our pointers from pointing your application to the primary to pointing it to one of the secondaries, and then the back end will spin up another secondary for you. So this can be really fast. And another benefit of business critical is you get to leverage one of these secondary replicas as a readable secondary. So you saw you got a readable secondary in a failover group. But with business critical, you get a readable secondary without configuring anything. And if you have a failover group, you can actually get, I think it's 3 readable secondaries with business critical. I'd have to think about the math again. But you get more with failover group, obviously. Now, what I want to show you, and this is fun if it works, is the difference, really the power pass. So failovers are fast regardless of what service tier, but how much faster business critical is than, say, general purpose. So I'm going to flip to my VM, and if you just bear with me while I pull up 1000 windows, and then I will explain to you what they are. All right. Oh, that's not what I want to do. One moment. Having some snapping issues. We'll just do it like that and drag this out. Thank you for hanging in there. Hopefully the questions are going okay. All right, so let me just make sure we're connected, and then I will explain to you this mess of things you're looking at. All right, looks like we're good on both of these. Okay, so what we have here is up top, you're seeing two notebooks side by side. You saw these notebooks before in the previous demo. But two notebooks side by side. One is for a general purpose database and one is for a business critical database. Now on the bottom, I'm using this tool called OStress. OStress, you've probably seen this before. It's an open source tool that you can use to create workloads. Now in the bottom left, I'm running on a general purpose database, the same one that I'm connected to in this notebook. And on the right, I'm running in a business critical database, the same one I'm connected to in this notebook. So I haven't configured anything. The only thing I'm doing is basically running this query. So what it's doing is it's saying select count from the sales LT customer table, and it's putting the output in a general purpose folder. So again, left side is general purpose. So we're just going to see 847. So this is really just simulating trying to make a connection repeatedly to the database for us to check, is the database available or not. Same over here, except we're running the same query, except it's on a business critical database. And we're just running this. This means we're going to run it 50,000 times. So it just allows me to generate a workload that we can kind of look at and compare the results. Now, the next thing I'm going to do is I'm going to invoke a failover. So I can actually invoke a failover using PowerShell, but we're just going to use this to simulate, okay, something happens and the service fabric has to fail us over for whatever reason. What happens? What's faster? How long does it take? So I'm going to kick both of these off, and I want you all to watch what happens. Remember, right side business critical, left side general purpose. Let me kick it off. Okay, so immediately when I kick that off, I see that business critical more quickly becomes unavailable and is available again before I can even explain what's happened. So it took maybe 3 seconds of me being disconnected, and that's really because we're just pointing you to the secondary. So we're just changing the pointer, and then in the back end we can update that secondary. So really exciting how fast it is. And you can see the general purpose one also has completed. It took a little bit longer because remember, it's like a failover cluster instance. So we're looking for a node with spare capacity, and then we're failing you over to that. Either way, whether you're failing over in 3 seconds or failing over in 30 seconds, this is very powerful that you get without doing anything. Like I said, I just deployed a database and started querying it and then invoked a failover. I didn't set anything up. I didn't have to configure anything. This is part of the SLA you get with Azure SQL database, and it's really quite cool. I get pretty excited with this demo. So again, I'm going to share these notebooks with you so you can try this for yourself and see that it's not magic. This is actually how it works, and you get pretty great availability in both service tiers in Azure. All right. So that's business critical and general purpose. And we'll compare all of these service tiers after I talk about the final service tier, which is hyperscale. Now, I do want to call out that hyperscale is not yet available in Azure SQL Managed Instance. It's something that we're working on, but something that's not quite there yet. But this is a really interesting service, and I'm not going to be able to do it justice in this session, but I want to give you kind of a high-level snapshot of what we've done. Basically, we re-architected SQL Server to be cloud native. And so we separated out various pieces. So what you're seeing here is the compute nodes. Now you can have primary and you can have multiple secondaries, and you can leverage those secondaries as readables. So we'll share a little bit more about that in a moment. And then we built this like really interesting caching system leveraging page servers. And you also get redundant log and data throughput through Azure Standard Storage. So since we're using snapshots, this can be done very quickly. And the other thing I wanted to mention, again, there's much more resources and videos that you should watch to learn more about this service because it is so interesting, is we pulled the log service completely out. So a transaction commit completes once once it hits the log landing zone, which you see over here. It doesn't have to solidify or harden in any of the secondaries, but then the log service is basically going to feed the replicas and feed the page servers. So it's really interesting. And, you know, as far as failover goes, I did want to mention that it's going to be dependent again on the service fabric. But like I said, and these should be secondary, but like I said, you can have 0, you can have 2, like you see here, you can have up to 4 secondaries. And if you have 0 secondaries, of course, your failover time is going to be similar to what you see in general purpose. Now, if you have more secondaries available, it's going to be more on par with what you're seeing in business critical. So that's hyperscale. So now you've kind of seen all the different service tiers, remembering that hyperscale is only available in Azure SQL Database today. And along the bottom, you're going to see a little bit of comparisons. And I actually noticed a typo here, which I will explain. So if we look at general purpose, again, this is going to be best for most business workloads, whereas business critical is going to be built best for those really mission critical applications, okay? And then hyperscale is going to be great if you have a lot of data, or if you don't want to be dependent on size of data operations. Because of the way we architected hyperscale, you can do things like change service tiers, scale up or scale down in constant time. This is something that doesn't quite apply in general purpose or business critical. So you can scale up a 60 terabyte database in a matter of minutes, which is awesome. As far as where your data is, you see where your data and log files are. In hyperscale, it's a combination of local and remote storage. And in both general purpose and business critical, you kind of saw in the architectures how those work. The second level of comparison is IOPS. Now with IOPS, if you're not familiar with this term, it's IO per second. Basically, I use the pluses to show what's going to get you more IOPS. So you're going to get the best IOPS in business critical, or the most IOPS in business critical. In hyperscale, you get somewhere between general purpose and business critical. You can get closer to business critical. It's just kind of going to depend on your workload. Now, my typo comes in at cost. From a cost perspective, I would say it's general purpose. That's a 1 money sign. So I was kind of playing off of Yelp. Then you have hyperscale, which is 2 money signs, and then business critical is 3 money signs. Business critical is going to be, you know, our most expensive offering, which is why, you know, we make sure we encourage you to use it only for your mission critical type of applications that need this low latency and need a readable secondary right off the bat. Business critical is also the only service tier today that supports in-memory OLTP. So that's something to consider if your workloads are leveraging that today, or you think they will leverage it in the future. And I mentioned this, but with hyperscale, you can get 0 to 4 readable secondaries. So that's why you see these 4 R's over here. Whereas in business critical, you can get 1, and in general purpose, you don't get any. So that's kind of the general comparison. Now, there's one thing I haven't mentioned, and that's this idea of serverless. I wanted to spend just a few minutes talking about what serverless is. And I want to do this by way of an example. And I'm going to take a bank. Let's say I work for a bank and we have a line of business application. It's a expense reporting application. So if you think about this, most people are doing their expense reports during the business hours. And so that means at night, nobody's really hitting this database. Additionally, when people were traveling for conferences, at the end of a conference month, you know, this app would get pounded because everyone's filling out their expense reports. But most of the month, and even most months, maybe it's not getting, you know, that much utilization. Now, as an application owner, you're having to make a decision between over provisioning and paying for it, or under provisioning and taking the performance hit when you do need this operation of scale or what have you. So this is kind of one scenario where serverless is going to be really great solution, because what serverless is going to allow you to do, if we take a look at an example and consider the bank. Let's say I have a 2-hour delay period. So what auto pause delay. So what that means is, you know, at 5 p.m. everyone goes home, they stop hitting that database. And so at 7 p.m. it's had 2 hours where no one tried to hit the database. And so what we're going to do is we're going to pause the database. What does this mean? This means we separate the compute from the storage entirely. We basically shut down SQL Server, and at that time, you're only paying for the storage, so your costs are very low. Now, in the morning, when someone logs in and they start to try to hit this expense reporting app, the first time it's going to fail because this database now needs to wake up. We need to reattach the compute and the storage, turn SQL Server back on. This takes about 30 seconds or so, depending on your connectivity. But once you're connected, then there's a little bit of a performance hit because you're starting with a cold cache, right? SQL Server was off, now it's on, so you start with a cold cache. But then what you're allowed to do is basically scale. So here you see I've set my min and max vCores as 1 to 4. So you can scale on a per second basis based on the max of CPU or memory that you need at any given moment. And we have a really interesting cache reclamation process that we use to kind of scale you back down. But you know, this auto scaling capability is really only available in Azure SQL Database Serverless. So this is a really interesting service. It's been really well received by our customers. It's also great for things like dev test workloads where, you know, you're only developing the application 8 hours a week. You don't want to pay for the database 40 hours a week, that sort of thing. Really great for what we call intermittent or unpredictable types of workloads. So that's serverless. And this is only available in Azure SQL Database in the general purpose service tier. Otherwise, you just pay for what we call provisioned compute, which basically means you say, I want 4 vCores, and you pay for 4 vCores for the month or duration until you change, regardless of how much exactly you use. All right, so let's take a step back. There's a lot of stuff on this slide, but I'm hoping now a lot of these things are starting to make sense. So if we look all the way to the right, we see SQL Server on Azure Virtual Machine. That's what we talked about. Maintain control over OS, but you also have to do patching. And we have some things to help you with things like scaling at HADR. We talked about instance pools, how this is going to allow you to migrate smaller instances and also lower that deployment time of MI. We talked about managed instance, a single instance. We talked about pools. We just talked about serverless. So again, you can optimize your price and performance for a very specific type of workloads. And then we talked about single database, which is the only place where you get hyperscale, which can again do this very quick scaling and constant time, and you know, reduces those size of data operations. And you can see some of the HA also represented below. So with that, I hope that was useful. I hope you learned something that was able to kind of demystify. And I have one more tool that you can go do today without doing anything and just kind of check out for yourself. And that is the Azure SQL, what we call the unified experience. So here I am, I'm in my Azure portal view. And in the portal, we used to have, well, we still have this thing called SQL databases. So I can click this and I can go look at all my SQL databases. But recently, we released this thing called the Azure SQL Blade. So I can click the Azure SQL Blade, and I can now drill in to, for a specific subscription, all the SQL services that I have deployed in the Azure SQL family. So whether it's a SQL database, an Azure SQL database server, a managed instance, a SQL virtual machine, I kind of get one pane of glass to see my entire SQL estate in Azure. So this is pretty cool. And I can also see things like the different service tiers, or even like in a SQL VM, what we're running. The other cool thing becomes the unified create. So if I hit add, what we're trying to give you here is kind of this tour of Azure SQL right in the Azure portal. So you can say, oh, I'm not sure if I want a single SQL database or a managed instance. So you can click in and see, oh, hyperscale is available in single database, so is serverless. Why might I use Elastic Pool? So you're kind of getting that tour and that what to use when from right in the portal. Now, the other thing, maybe in my opinion, I think the best thing about this Azure SQL Create experience is consolidating all of these SQL virtual machine images. Before, you had to go hunt for the exact OS SQL Server version that you wanted, the type of license, and we've made that so easy here. So what you're seeing is I can say, oh, you know what, I have a 2008, and then I can select either the bring your own license or the regular, and I can pick the option of the OS version as well. We also have images for Linux like RHEL, Ubuntu, SUSE Slash, lots of options here. From the licensing as well, if you want to do the developer edition or Express, lots of options. So this is really going to help you get your SQL Server in an Azure virtual machine without having to install SQL Server. So this is kind of cool, and I like to end on this note because it kind of gives you something to go look at in the portal right now and see what to use when without even having to deploy anything. Now I have a few things because, like I said, I know we covered a lot of information. I hope that you were not overwhelmed and you now feel empowered that there are a lot of options and opportunity for you and your business and your projects in Azure SQL. I always laugh at this, but I do like this sentiment a lot. Like I said, Bob and I have been working on this. So this is a Bob statement. He says, Azure SQL has evolved into the world's database. And maybe it's a little cheesy, but I think, you know, that's really what we're going for. You know, we want to run the best database on the planet. And so we want to continue to innovate so we can keep you folks, our SQL base, our SQL Server base, with us in SQL Server and with us in this journey to the cloud. Oh, we also talked about the power of PaaS. I don't want you to forget the power of PaaS. And now I want to share a few resources. This one, so I mentioned that we recently went through this rebranding Azure SQL launch. There's a lot of things involved with this launch. Outside of the portal that you just saw, we have a whole new website, and part of that website, which you can find at this URL, basically asks you like 3 questions and then says, hey, we think SQL Server and Azure Virtual Machine is the best option for you, or hey, we think serverless is the best option for you, or hey, you know, it'll actually help you choose just by answering a few questions. So definitely check that out. It's cool, even if you don't have a project to use, just to kind of learn more and kind of, you know, predict where you think you're supposed to end up. Now that's this second link here that you see in my resources. There are a few other resources I wanted to mention, and then I'll start to look at the questions and kind of see what else I can help answer. The first is the Azure SQL workshop. Now, like I mentioned a few times, probably too many times, Bob and I have been working on this thing called the Azure SQL workshop. I started working on it, you know, maybe December, January, and then I reached out to Bob and I said, Bob, I know your SQL Server expert. I want you to take a deep dive look with me and help me create this Azure SQL workshop so we can bring the SQL Server community to Azure SQL. And so it's been really fun. I've learned a lot. You know, he's hyper focused, and so we've gone into a lot of the details and testing and comparing. It's been a lot of fun. And we're working on putting all of those learnings into the aka.ms SQL workshop site. So if you go to that site, you can select the Azure SQL workshop and you can monitor our progress. That's going to include today, it's going to include all the demos you saw today, including a bunch more demos around performance, more around availability, around security, around deploying and configuring, and a ton more information. We're also working on some content for Microsoft Learn and a whole YouTube series, so you're definitely going to want to keep following this if this is something you're interested in learning more about. I also linked to the Azure SQL docs. Really useful. If you have a question, I recommend going to your favorite search engine, typing Azure SQL, whatever your question is, and then docs. That's going to help you find an answer. Finally, I have a shameless plug. Through Microsoft Developer, we run a series on YouTube and Channel 9. It's called Data Exposed. It's largely focused on Azure SQL and SQL Server because I host it, so I tend to bring people from our community on. We're ramping up to launch an MVP edition in July, so that'll be fun. But right now our episodes are on Thursdays. They launch at, I can't remember what time, but Thursday mornings Pacific. So we hope that's something you'll subscribe to and you'll get to see from myself, but more you're going to get to see from the other members of our team because I bring them on and we talk about topics at a high level and we deep dive in topics, we show demos, we bring on external folks. It's really just a fun show and kind of has something for everyone. With that, I will kind of stop rambling. I'll put up my Twitter handle. You can, of course, follow us on Azure SQL, but you can also direct message me if you have any questions or connect with me on LinkedIn or that sort of thing. And I just thank you and thank Jason and Pass and Eric for setting this up. And I will wait patiently for questions. Hopefully I can answer.
All right, we do have a few questions. So the first one here, and before I get into the question, thank you, Anna, for this for speaking today. This has been great. So
Yeah, of
it
course.
was very helpful for myself. So first question is how do you turn off automatic index creation if you no longer need it?
Yeah, that's a great question, and it's actually really easy to do. So here, just because it's easy to show you all here, in the portal, I can actually select in here and I can see what my settings are. So I can either inherit them from the server, so all databases that I have in that Azure SQL database server, or I can set it for specific databases and I can change it with just a few clicks of a button. So for example, if I wanted to turn off create index, because we turned it on in this demo, I just hit apply and okay, and it's off. Hopefully that helped.
Oh yeah, excellent. And then we had a previous question that talked about an Azure SSRS template, and the answer had been that there's an active project working on it, and so the questioner had a follow-up about whether or not there is access to that SSRS project within Azure. There's some sort of timeline for availability there.
Gotcha. That I would not be familiar with. I have heard that we are working on something. For a timeline, what you can do is shoot me an email and I can find out. Here, let me do this. Yeah, because sometimes I know the answer to questions and sometimes I don't. But you can always reach out to me and I will try my best to answer. Let me see. I'll make that bigger. So yeah, if you want to shoot me a email about the SSRS, I'll point you off to someone who can answer it.
Excellent. And I know that this is a fairly common question that we do get regarding SSRS.
Oh, gotcha. Yeah.
And then from a learning perspective, I know you showed a few things, but from a learning perspective, what is your recommendation for getting a sandbox Azure portal with minimum cost?
That is a great question. So yeah, I mean, it's just to give a little background on this question because I think it's a valid one. Currently today, if you go in the Azure portal, there is no free Azure SQL tier. You can sign up for an Azure free trial, and that's going to give you, I think, $200 worth of credit for the course of a year. So you can just Bing or Google that Azure free trial. So that's one option to choose. There are complications with this, and if you really want a great sandbox environment for free, with no subscription rights, you should stay tuned for August because we are building out a whole learning pathway on the Microsoft Learn infrastructure. And so what this allows us to do is basically give you a sandbox environment just attached to your email, not any work subscription, anything like that. And then you can actually go and deploy and play with these resources for free. So that's a really exciting thing that we're doing. It's a great question. It's a question we get a lot and haven't had a good answer to. I know it's June and I said August, so I still don't have the best answer to it. But until August, I would say, you know, explore the Azure free trials that are available through search engines. Otherwise, you know, stay tuned for August when this story gets, you know, a lot better. And check out Microsoft Learn.
All right, excellent. Thank you, Anna. That does cover, it looks like, all the questions that we had. So everyone, thank you for attending today. Thank you, Anna, for presenting. Look forward to having you back here if you're interested to speak some more.
Yeah, would love to. And thank you all again.
All right. And everyone have a great rest of your day. And with that, I'm going to close things out. So thank you and goodbye.